What's up, guys? It's me, Sir Ernest, and today we're going to calculate the moment of inertia of a circular disk rotated about an axis perpendicular to the disk and passing through its center. Here, our view is in a front view. That means the axis of rotation is pointing away or toward you. So this will be our axis, and that is perpendicular to the screen where your circular disk lies. Let's say, for example, that the disk has a radius A. So this will be your radius. Let's call this radius A. And then let's say the mass of your circular disk is given as M. As I mentioned earlier, the axis of rotation is perpendicular to the disk passing through the center. So here, our dm would be in terms of a surface. So our dm, or the element mass, will be rho ds. So what is our ring element? So our ring element would be this element. Okay, so let's define it as follows. Of course, you have your ring surface, and then this is subtended by these two lines, this line and this line. Okay, and this is angle d theta. So this d theta will be integrated from 0 to pi to make one full circle. Also, the thickness of this ring is dr. So this is dr. And then the distance between the center to this ring is r. So ds is now equal to the area of this infinitesimal square. So that is r d theta dr. So the moment of inertia I is equal to the integral of r squared dm. So the distance of your area element ds would be r. So this will be retained. So this is integral of r squared. And then dm will be rho ds, where ds will be r d theta dr. So here, if we assume that rho is uniform and this is equal to mass over area, because this is a surface element, therefore, this will be equal to rho times the integral of r cubed dr times the integral of d theta. So this is now a double integral whose limits of integration are as follows. For r, the limit of integration will be from 0 to a. So this is 0 to a. While, as I mentioned earlier, theta will be integrated from 0 to 2 pi. So solving for this integral, this becomes rho times a to the fourth over 4 times 2 pi. Simplifying this, we now have 2 pi. Since the area of your disk is pi a squared, that means this pi times a squared of this a to the fourth will be equal to a. So doing the substitution, this becomes a rho times a squared over 2. Since the mass of your object is equal to a times rho, therefore, the moment of inertia will be equal to 1/2 m a squared. So therefore, this is now the moment of inertia of a disk rotated about an axis perpendicular to the disks passing through the center. And this is equal to 1/2 m times the square of the radius of the disk. Simple, right? So this is the moment of inertia of this circular disk. So that's all for now. Thank you guys for watching, and I'll see you guys in the next video. Bye-bye.